Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are discussing our lecture number 4. Course title is Advanced Physical Chemistry and course is the Conductometry. Course code is CHEM3117. I am Dr. Rana Farad Mahmood. Let us start our topic. Dear students, here we are some contents. Number 1 is determination of activity. Number 2 is mean ionic activity coefficient. And number 3 is Debye-Huckle theory limiting law. So, in our slide number 4, we are discussing about mean ionic activity coefficient by Graphically method. We have 3 beakers. In first beaker, we have a concentration of any salt 1 millimole in 1 kg H2O, means water, and we have 2 moles in 1 kg H2O in the second beaker, and we have 4 moles of NaCl. So in the first 2 beakers we see that we have taken concentration as molality, because molality deals with the kilogram of the solvent. Okay, in the 2 beakers we have one thing seen, that there is amount of current 0.1 ampere in both is same. As we have 1 millimole in 1 kg H2O in the first beaker, so there is 0.1 ampere, but when we talk about second beaker, there is increase of concentration 2 moles. When molality is increased, so the current should have increased because the ions are added, but current remains same. The main reason is that when molality is increased, then ions are increased, but these ions which have increased number have their attractive forces among them, and these attractive forces causes them to create hindrance, to create attractiveness, and due to hindrance attractiveness less ions are moved, less ions are mobile, so their mobility is restricted. Okay, in beaker number 3 we have 4 moles of NaCl, so we have very high concentration of NaCl, so there are more repulsive forces than their attractive forces. When repulsive forces increased, then their ionic sphere breaks. When ionic sphere breaks, then more ions are capable to mobile, so mobility is increased. Then current of 10 ampere is seen. So students, in the below of beaker number 3 there is something written that gamma is called mean ionic activity coefficient. In our last lecture we have discussed it, that gamma is equal to A over C. A means activity, means mean ionic activity, and C is the concentration. So graphically, if we see that gamma is taken on y-axis and the concentration is taken on x-axis. Okay, for gamma is equal to 1, we should have noted that A will be equal to C, means activity is equal to concentration. If there is 2 mole of concentration, then there is 2 active ions, means 2 activity. So 2 over 2 will equal to 1. As we increase concentration, means as we go from very dilute concentration to the concentrated solutions, then attractive forces come across the ions and restrict their mobility activity. So A will be less than C, and when we increase concentration further, a point is reached where gamma is minimum. When gamma is minimum, then at that point repulsive forces will be equal to attractive forces. When we increase much concentration, as in equation number 3, 4 moles of NaCl, then there is sudden increase in the value of gamma, and it increases from 1 also. So here at this point the repulsive forces will dominate over attractive forces. Dear students, in this slide we are discussing about mean ionic activity. As we know that A over C is equal to gamma in the right side of slide, then here we are taking concentration in molality, so we write C is equal to M. So it becomes that A over M is equal to gamma, where A is activity, mean ionic activity, M is molality, and gamma is the mean ionic activity coefficient. Then A will be equal to gamma M. Okay, let us suppose an example of NaCl. NaCl is the univalent salt, means it has +1 charge, +1 cation, and also 1 anion. So it is a salt which has univalent cation, and univalent anion. So it is called univalent. So let us suppose generally that a salt we have taken as electrolyte is AXBY. X is the number of moles of A and Y is the number of moles of B. So if we dissolve it in the water, it is dissolved into their respective ions in this way that AXBY will change into XA positive, means X is the number of moles of A cation and Y is the number of moles of anion, YB negative. So we can say that number of moles of cations, means it shows that how much cations are excluded. So it will be called its mean ionic activity of cation. So mean ionic activity of cation is X, mean ionic activity of anion is Y. So here we can write a relation that A means ionic compound of A into ionic compound, means activity of any ionic compound is equal to A positive into X. It means that the number of moles of cationic activity and into anionic activity. A negative into Y. Mean ionic activity A positive is equal to M positive, gamma positive, and A negative means mean ionic activity of anion is equal to M negative into gamma negative. In the right side of slide we have proved that A is equal to gamma M. So if we have M positive, then it will be equal to xm, and if we have M negative, then it will be equal to ym. Okay, let us put the values of M positive and M negative in the left side equation of slide, which is equal to A is equal to A positive into x, its power to x, and into A negative its power to y. So put the value of A positive and A negative. A positive will be equal to M positive gamma positive into raised to power x multiplied by M negative gamma negative raised to the power y. Then put the value of M positive and M negative. We have xm gamma positive raised to power x into ym gamma negative raised to power y. Okay, when power is applied in the inside values, then x power x into m raised to power x, then gamma positive raised to power x into y raised to power y into m raised to power y into gamma negative raised to power y, which is equal to x raised to power x into y raised to power y, and being m as common base, then adding their powers is equal to m in m raised to power x plus y, then gamma positive negative raised to power x plus y, which is equal to mean ionic activity coefficient. Then this equation is generally becomes that A is equal to x raised to power x, y raised to power y, m raised to power x plus y into gamma positive negative raised to power x plus y. Okay students, here we will discuss about how we will calculate mean ionic activity of different salts. First is NaCl. This is univalent cation and univalent anion. When it is dissolved in water, then 1 mole of cation is obtained and 1 mole of anion is obtained. X-Y ratio is 1:1. Putting values in formula, we have m square and lambda positive negative square. It is the value of mean ionic activity of NaCl. Same is the method and formula and the values for KCl. Also it is univalent salt. Next is sodium sulfate. When it is dissolved, then it excludes 2 mole of cation and 1 mole of sulfate anion. The ratio of x and y is 2 and 1. When we put values of x and y in formula, we get the value of A is 4m cube into gamma positive negative cube. So H2SO4 is the same case as sodium sulfate. We have the values of x and y as 2:1. Putting values, then we have get the value of mean ionic activity as 4m cube and gamma positive negative cube. Then we have another salt, aluminium chloride. It is a univalent cation and trivalent anion. So the ratio is x and y is 1:3. 1:3, putting values 1, 3, then we get the value of mean activity of aluminum chloride is 27 m raised to power 4 into gamma positive negative raised to power 4. Here is some important terms that this is an important topic. Debye-Huckle law, it is also called Debye-Huckle theory, it is also called Debye-Huckle limiting law. What does it tell us? It tells an inverse relation between mean activity gamma and ionic strength mu r I, denoted by mu r I. If so, what is ionic strength? Ionic strength is the amount of, basically it is the number of coordination, means how much number of surrounding ions are present around an ion, around an anion, then it will be its ionic strength. If there are 4 anions around a positive ion, and if there are 5 anions around positive, then 5 will be more ionic strength of that cation. Okay, if there is an increase in ionic strength, then mean an activity coefficient means gamma will be increased. Okay, we have formula A is equal to gamma C, and gamma mean and activity coefficient is equal to A over C. So if we have 1 molar concentration of solution, then in this solution how much active ions are present is basically its activity. If we take 1 molar, then we see that 1 ion is active, so the ratio between A and C is 1:1, then the gamma will be also 1, which is its maximum value. Okay, ionic strength, it tells how much ions are surrounding around any ion. It is directly related to concentration and valency, which will be explained next. So here are two types of ions. One are positives, and around positive there are some negative ions, and the empty circles are for polar compounds, means somewhere polarity is induced, then their ionic strength is increased. If polar compounds are present around any ion, then ionic strength is increased. So in the right side we have an ion, means negative ions. Around this negative ion we have cations that are surrounding it, so its ionic strength is also increased due to polarity, empty circles. Okay, here is some more explanation that Debye-Huckle law, what is it about? Okay, the I represents ionic strength, which depends on two things. One is concentration and other is valency, and how it depends will be explained in next slides. We have a formula A is equal to gamma into C. If a positive negative means mean an activity for positive and negative both, so the gamma positive negative is mean an activity coefficient for both ions. So gamma positive negative mean an activity coefficient is related to ionic strength as inversely. If I or mu is increased, then gamma positive negative will be decreased. So in the right side of the slide we have some value of gamma positive negative mean ionic activity coefficient will be 1 for ideal solution. Here A will be equal to C, means activity will be equal to concentration. And if the value of gamma positive negative will be increased from 1, then there will be non-ideal solutions. For them A will be greater than C, and in the right side, in the left side, if we have a value of gamma positive negative less than 1, it means that A less than C, means C is greater, concentration is greater. So when the below denominator is greater than the value of the formula is less than 1. Okay, here one thing is notable, that gamma positive negative has a less value. When it has less value, then through Debye-Huckle law it is related to inversely of any system, then any system will be higher. Here is some explanation that what is the effect of changing concentration and valency on gamma positive negative mean ionic activity coefficient and on ionization strength. As we know that ionization strength is directly proportional to concentration, means concentration, if we increase, then ionization strength will be increased. It means that the concentration is increased, then ions are increased. When ions are increased, then their ionization strength is increased. So if we have 0.1 molar NaCl and 0.2 molar NaCl and 0.3 molar NaCl, then their ionization strength will be increased, going down. So ionization strength also directly related to the valency, means some salt we have univalent such as NaCl. So if we take their concentration constant 0.1 molar NaCl and 0.1 molar bivalent univalent MgCl2 and 0.1 molar AlCl3 trivalent univalent salt, then going down we increase valency, being remained the concentration as constant, then what will happen? It is seen that when valency is increased, then charges are increased, then attraction increased, and ionization strength is increased. Here is Debye-Huckle law mathematically, that log gamma positive negative to the base 10 is equal to minus a into mod into z positive into z negative mod into square root of ionization strength, where a is constant for solvent in which electrolyte is dissolved. For water it is equal to 0.529 or 0.509. Then z positive is equal to charge of cation, z negative is equal to charge of anion. So when we take their mode, then we talk about only their magnitudes. Okay, in the right side corner a box is given where gamma positive negative is related to ionization strength as inversely relation. A positive negative is equal to gamma positive negative C. Okay, when gamma positive negative is equal to 1, then A is equal to C. When it is increased from 1, then A is increased from C. A is greater than C, and when it is decreased from 1, its value is less than 1, then it shows that A is less than C. Okay, in the below we have I is equal to 1 over 2 summation Ci into Zi square. It is the mathematical formula for the calculation of initial strength. Basically, it is summed up the concentration of both ions. Ci means concentration of both ions, positive and negative, and Zi is charges of both ions. Then it is taken their square. Okay, here is some graphical explanation of Debye-Huckle Law, and here we will see that how it is called as Debye-Huckle limiting law. Okay, we have taken three sources. One is NaCl, second is AlCl3, one is NaCl means univalent, second is AlCl3 trivalent univalent, and then calcium sulfate bivalent. One thing is notable that we have taken slope, their slope means minus log gamma positive negative to the base 10 in the below y-axis, mean in the negative y-axis. So why we have not taken this on the positive y-axis? The reason is that we are talking about slope, which is equal to, in the top right corner of slide, is minus log lambda gamma positive negative to the base 10 is equal to a mod z positive into z negative mod square root of I. So minus log gamma positive negative to the base 10 is the value that is given for the source. So as minus log gamma positive negative to the base 10 is taken on negative y-axis, so we have the slopes on the negative y-axis. Okay, for NaCl the straight line slope is obtained. Why it is obtained as straight line? Because it is obeying straight line equations. So what is straight line equation is explained on the right side of slide. First of all, we have calculated their gamma positive negative as, we know that NaCl is univalent means it has one cation and one anion. So Z positive into Z negative will be equal to 1 into 1 is equal to 1. So A is constant, I is constant, so its value is 1A square root of I. Then down in the below, aluminum chloride has 3 cation and 1 anion, so when we multiply 3 into 1, then it comes that 3A into square root of I. Then we calculate for calcium sulfate, it is equal to 4A into square root of I. And next we have minus y is equal to mx. Basically it is a straight line equation. The solution which follow this equation are ideal solution. That ideal solution are at very low concentration or at very dilution. Means if we have very low concentration, means at O point on x-axis, then these solutions are ideal because they have very low concentration. The ideal solutions are those which have very low concentration and have very low attractive forces in between their ions. If we increase concentration from left to right on x-axis, then the ideality is not remain same. as in curves of blue lines of graph that it is not a straight line, so it does not follow straight line equation. So these are non-ideal solutions at higher concentration. For non-ideal solutions at higher concentrations, we have an equation, a modified law, in which we have modified that we have added the Ci. The equation is minus log gamma positive to the base 10 is equal to A in mod z positive into z negative mod square root of I plus C into I. C is concentration and I is the ionic strength. So we have added something, so it is a modified law. It is also called a limiting law. So here we are calculating the effect of changing concentration on gamma, means mean ionic activity coefficient, and on mu or ionic strength. First case is that 0.001 molar NaCl is taken. So it is univalent salt. Z positive is equal to +1, Z negative is equal to -1. Putting values in equation of ionic strength is 1/2 into 1/2 into Ci square into Zi square. So Ci for both ions. So first we will calculate for cation and then we will add for it for anion. Okay, C is given, concentration is given 0.001 into Z positive is 1, so 1 square 0.1 0.001 plus 0.001 multiplied by 1 square. So value of ionic strength is 0.001 square root. If we take, then it comes out that 0.03162 value of square root of I. Okay, in the below we have formula of Debye-Huckle law. Log gamma positive negative to the base 10 is equal to minus A into mod into Z positive into Z negative, then mod, then square root of I. So putting values, we have the amount of mean ionic activity gamma positive negative is 0.9957. The same method is applied for the second section is 0.002 mole NaCl. The ionic strength for it is 0.002. As we note that when we increase concentration from 0.001 to 0.002, then I is increased, ionic strength is increased. When we see that ionic strength is increased as we increase concentration, but the gamma mean ionic activity coefficient is decreased from 0.9957 to 0.9489. The second thing is that calculating the effect of changing valency on gamma means mean activity coefficient and on ionic strength. First case is 0.002 molar of univalent. Then second case is 0.001 molar MgCl2 means bivalent univalent. Here valency is increased, concentration is decreased. Then putting the values, we have see that for univalent I is equal to ionic strength will be 0.002 and for bivalent it will be 0.003. So the valency is increased, then their ionic strength is increased. When ionic strength is increased, then their gamma positive negative value mean ionic activity coefficient will be decreased, as ionic strength is inversely related to the mean ionic activity coefficient. So gamma positive negative for first case is 0.9489, and for second case it is gamma positive negative is equal to 0.2770. Thank you so much. Allah Hafiz. Allah आपका निगहबान.